Hello students, how are you? Saryanu Sat Shri Akal. I am Gagandeep Singh from Department of Physics, Khalsa College for Women, Sidhwa Khurd. Today I will deliver a lecture on oscillators. There are different type of oscillators. These five type of oscillators which I have shown in this slide, they are in our syllabus: tuned collector, Hartley, Colpit, phase shift and Wien bridge. Now, first of all, we will discuss what is oscillator, its theory and principle. So, by definition, oscillator is a device which converts DC voltage into AC voltage. As we have seen in rectifier, it is said that rectifier it converts AC voltage into DC voltage. So, oscillator it works just opposite to rectifier. And also here we find that we obtain output voltage even if external input signal is 0. So even if external inputs is not there, still we get continuous voltage, sinusoidal voltage in an oscillator. So we will discuss mainly feedback oscillators with sinusoidal output. So this is a special category of oscillators, that is feedback oscillators, whose output is sinusoidal. Sinusoidal means that the output is in the sine wave, is the sine wave. So in the theory, the main thing which you should understand in oscillators is positive feedback. As you can see in the diagram, you find an amplifier whose gain is A. A portion of its output voltage V0 is being fed back through the feedback network to the input. This diagram is familiar to you as we have done this in our previous classroom lecture of feedback amplifiers. The only difference here is that here Vi, which is the input voltage to the amplifier, it is Vs plus Vf. We will take plus sign so that Vs and Vf both are in same phase, that is zero phase difference, and which results in positive feedback. In oscillators, we take external input voltage 0, that is Vs equal to 0. Now, if Vs is equal to 0, then if we solve this above expression, then we find that we reach a condition uh, beta A equal to 1. Beta A is the loop gain. So that means beta A is equal to unity. This is a very important condition which an oscillator has to satisfy. And this condition or criterion is called Barkhausen criterion of sustained oscillations. So it's the main thing or the main requirement which oscillator should always obey so that it could produce sustained oscillations. Now, there are different cases. Now, if the loop gain is less than 1, then you can easily find from the previous circuit diagram that the with feedback the input voltage beta Vi, it will become, or it will rather decrease with respect to Vi. That means the oscillations which we obtain from the oscillator, it has decreasing amplitude, as I've shown in the slide, that as the time passes, the amplitude of the oscillations goes on decreasing. Similarly, if the loop gain is greater than 1, then also the amplitude, it does not remain constant, but now it is increasing with time. It is only if beta is equal to unity then we get oscillations of constant amplitude, and that is our main requirement, which we call Barkhausen criterion of sustained oscillations. Now, to build a oscillator, there are three main essential components which are required. First is tank circuit. As you can see in the diagram on the right side, that there is a tank circuit constituting an inductor L and capacitor C. This tank circuit, it determines the frequency, that the output of the oscillator which we get, how much is the frequency of that oscillations. That is decided by this tank circuit. So this tank circuit is used to produce electrical oscillations. ਤੁਸੀਂ ਲੋਅਰ ਕਲਾਸਿਸ ਦੇ ਵਿੱਚ ਇਹ ਪੜ੍ਹਿਆ ਇਲੈਕਟ੍ਰੀਸਿਟੀ ਦੇ ਵਿੱਚ +2 ਦੇ ਵਿੱਚ ਵੀ B.Sc ਫਸਟ ਈਅਰ 'ਚ ਵੀ ਕਿ LC oscillations ਆਪਾਂ ਨੂੰ ਮਿਲਦੀਆਂ ਨੇ ਜਿਨ੍ਹਾਂ ਨੂੰ ਅਸੀਂ ਇਲੈਕਟ੍ਰੀਕਲ oscillations ਕਹਿੰਦੇ ਆ when we take inductor and capacitor. So same that combination of inductor and capacitor is used here also to obtain oscillations. Second component है amplifier. Now ਜਿਹੜੀਆਂ LC oscillations ਜਾਂ ਟੈਂਕ ਸਰਕਟ 'ਚ oscillations ਮਿਲਦੀਆਂ ਨੇ ਉਹ ਹੌਲੀ ਹੌਲੀ ਉਹਨਾਂ ਦਾ ਐਂਪਲੀਟਿਊਡ ਘਟਣ ਲੱਗ ਜਾਂਦਾ। ਕਿਉਂ ਘਟਦਾ? Due to resistance in the circuit. So to increase the amplitude or the strength of the signal, we use amplifier. That is why the oscillations which we obtain from tank circuit, they are fed to the amplifier. So amplifier as usual अपन पता ही amplify कादे वास्ते आप use करते हैं to increase the amplitude of oscillations. Then the third component, main component is the feedback circuit. Now feedback circuit की करता वा, it transfers a part of output energy, ਜਿਹੜੀ output voltage ਜਾਂ energy ਆਪਾਂ ਨੂੰ amplifier ਤੋਂ ਮਿਲ ਰਹੀ ਹੈ ਉਹਦਾ ਕੁਝ ਹਿੱਸਾ ਇਹ feedback network ਵਾਪਸ ਭੇਜਦਾ ਵਾ to the tank circuit. ਟੈਂਕ ਸਰਕਟ ਦੇ ਵਿੱਚ ਭੇਜਣਾ ਕਿਉਂ ਭੇਜਣਾ ਹੈ? ਬਿਕੋਜ਼ ਉੱਥੇ ਲੌਸਿਸ ਹੋ ਰਹੇ ਨੇ ਜਿਹਦੇ ਕਰਕੇ ਟੈਂਕ ਸਰਕਟ ਦੇ ਵਿੱਚ oscillations ਦਾ ਐਂਪਲੀਟਿਊਡ ਡਿਕਰੀਜ਼ ਕਰ ਰਿਹਾ ਵਾ ਟੂ ਕੰਪਨਸੇਟ ਡੈਟ ਐਂਡ ਟੂ ਪ੍ਰੋਵਾਈਡ ਪ੍ਰੋਪਰ ਫੇਜ਼, ਕਿਉਂਕਿ ਆਪਾਂ ਨੂੰ ਇਹ ਵੀ ਪਤਾ ਕਿ ਪੋਜ਼ਿਟਿਵ ਫੀਡਬੈਕ ਚਾਹੀਦਾ। ਸੋ ਆਲ ਦਿਸ ਇਜ਼ ਡਨ ਵਿਦ ਦ ਹੈਲਪ ਆਫ ਫੀਡਬੈਕ ਸਰਕਟ। ਨਾਓ ਨੈਕਸਟ ਇਜ਼ ਫਸਟ feedback oscillator, that is tuned collector oscillator. I have drawn a circuit diagram of this oscillator. So ਜੇ ਆਪਾਂ ਨੂੰ oscillator ਦਾ basic principle theory ਪਤਾ ਆ ਤਾਂ ਫਿਰ ਇਹ oscillators ਨੂੰ ਸਮਝਣਾ ਕੋਈ ਜ਼ਿਆਦਾ ਮੁਸ਼ਕਿਲ ਨਹੀਂ ਹੈ। ਮੇਨ 3 ਕੰਪੋਨੈਂਟਸ ਨੇ, ਅਸੀਂ ਉਹਨਾਂ ਨੂੰ ਹੀ ਡਿਸਕ੍ਰਾਈਬ ਕਰਨਾ ਹੈ ਜਦੋਂ ਵੀ ਅਸੀਂ ਸਰਕਟ ਨੂੰ ਡਿਟੇਲ ਦੇ ਵਿੱਚ ਦੱਸਣਾ ਆ। ਤੁਸੀਂ ਦੇਖ ਸਕਦੇ ਹੋ ਕਿ ਟਿਊਨਡ ਕਲੈਕਟਰ ਦੇ ਵਿੱਚ ਇੱਕ ਐਂਪਲੀਫਾਇਰ ਹੈ, ਕਾਮਨ ਐਮੀਟਰ ਟ੍ਰਾਂਜ਼ਿਸਟਰ ਐਂਪਲੀਫਾਇਰ ਇੱਥੇ ਪਿਆ, NPN ਹੈ। ਸੋ ਇੱਕ ਐਂਪਲੀਫਾਇਰ ਹੋ ਗਿਆ, ਇੱਕ ਆਪਾਂ ਨੂੰ ਚਾਹੀਦਾ ਹੈ ਫੀਡਬੈਕ ਨੈਟਵਰਕ। ਸੋ ਫੀਡਬੈਕ ਦੇ ਵਿੱਚ ਕੀ ਹੈ? ਆਹ ਇੱਕ ਟੈਂਕ ਸਰਕਿਟ ਹੈ। ਟੈਂਕ ਸਰਕਿਟ ਜਿਸ ਤਰ੍ਹਾਂ LC oscillations ਪ੍ਰੋਡਿਊਸ ਕਰਦਾ ਉਸੇ ਤਰ੍ਹਾਂ ਇਹ ਇੱਕ ਟੈਂਕ ਸਰਕਿਟ ਹੈ। ਇਹਦੇ ਵਿੱਚ L ਅਤੇ C ਵੇਰੀਏਬਲ ਆ ਤਾਂ ਕਿ C ਦੀ ਸੈਟਿੰਗ ਕਰਕੇ ਅਸੀਂ ਫ੍ਰੀਕੁਐਂਸੀ ਨੂੰ ਵੇਰੀ ਕਰ ਸਕੀਏ। ਸੋ ਟੈਂਕ ਸਰਕਿਟ ਹੈ, ਇਹ oscillations ਪ੍ਰੋਡਿਊਸ ਕਰਦਾ। L ਦੇ ਕ੍ਰੋਸ ਜਦੋਂ oscillations ਪ੍ਰੋਡਿਊਸ ਹੁੰਦੀਆਂ ਨੇ ਇੱਕ ਵੋਲਟੇਜ ਪ੍ਰੋਡਿਊਸ ਹੁੰਦੀ ਹੈ। ਇਹ ਜਿਹੜੀ ਵੋਲਟੇਜ ਹੈ ਉਹ ਡਿਊ ਟੂ ਮਿਊਚੁਅਲ ਇੰਡਕਟੈਂਸ ਇਹ L1 ਅਤੇ L2 ਨੂੰ ਟਰਾਂਸਫਰ ਹੋ ਜਾਂਦੀ ਹੈ ਡਿਊ ਟੂ ਮਿਊਚੁਅਲ ਇੰਡਕਸ਼ਨ। ਨਾ ਜਿਹੜੀ ਤਾਂ L2 ਦੇ ਕ੍ਰੋਸ ਜਿਹੜਾ ਇੰਡਕਟਰ ਆ ਉਹਦੇ ਕ੍ਰੋਸ ਵੋਲਟੇਜ ਮਿਲਦੀ ਹੈ, ਡੈਟ ਇਜ਼ ਦਾ ਆਊਟਪੁੱਟ, ਉਹ ਆਪਣੇ ਲਈ ਆਊਟਪੁੱਟ ਹੈ। ਅਤੇ ਜਿਹੜੀ L1 ਦੇ ਕ੍ਰੋਸ ਮਿਲ ਰਹੀ ਹੈ ਵੋਲਟੇਜ ਆਊਟਪੁੱਟ, ਡੈਟ ਇਜ਼ ਫੈਡ ਬੈਕ ਟੂ ਦੀ ਟਰਾਂਜ਼ਿਸਟਰ। ਤੁਸੀਂ ਦੇਖ ਸਕਦੇ ਹੋ ਕਿ ਦ ਆਊਟਪੁੱਟ ਅਕ੍ਰੋਸ L1 ਇਟ ਇਜ਼ ਫੈਡ ਬੈਕ ਟੂ ਦੀ ਬੇਸ ਆਫ ਦਾ ਟਰਾਂਜ਼ਿਸਟਰ ਔਰ ਐਂਪਲੀਫਾਇਰ। ਸੋ ਟੈਂਕ ਸਰਕਿਟ ਵੀ ਆਪਾਂ ਨੂੰ ਪਤਾ ਚੱਲ ਗਿਆ ट्रांजिस्टर एम्पलीफायर लगे हुआ है। नाउ हाउ टू ऑब्टेन पॉजिटिव फीडबैक, किमें पॉजिटिव फीडबैक मिलेगा। देखो ਜਿਹੜਾ ट्रांजिस्टर है कॉमन मीटर, ਇਹ ਇਹਦੇ ਇਨਪੁਟ ਤੇ ਆਊਟਪੁੱਟ ਦੇ ਵਿੱਚ 180 ਦਾ ਫੇਸ ਡਿਫਰੈਂਸ ਹੁੰਦਾ, that we know from the past. Now 180 ਦਾ ਪਾਸ ਡਿਫਰੈਂਸ ਪ੍ਰੋਡਿਊਸ ਕੀਤਾ ਐਮਪਲੀਫਾਇਰ ਨੇ। ਆਲਸੋ ਜਿਹੜਾ L1 ਤੇ L ਹੈ, both are mutually coupled by mutual induction. So voltage, there will be a phase difference between the voltage between L and L1, and that phase difference is 180 degree. Therefore total phase difference becomes 180 from the transistor and 180 due to mutual induction between L1 and L2. Therefore the feedback voltage, the input voltage from L1 which is given to base, it has a phase difference of 360 between the previous input voltage. So 360 means 0 degree phase difference, that is positive feedback. So that is how we get a positive feedback. Other these set of resistances R1, R2, or this battery B.Sc, this resistance Re, so they are just there to, they act as a transistor biasing circuit, and this is a voltage divider bias. As we have seen in the previous chapters, that the voltage divider bias is the best biasing circuit to fix the Q point. So therefore we use that biasing circuit. These capacitors C1 and CE, they are used to bypass the AC, because as we know that AC can be easily passed through a capacitor. So that is the main working of this tuned collector oscillator. Now whatever I have said in the previous slide, I tried to write it in this slide, so you can study this slide, and you should write the main points from this slide, that you should also write in your paper also. Now the mathematical analysis which we want to do, for this I have to draw a H parameter circuit. This thing we have also done in the 5th semester. Here we have a voltage source HREV0, a current source HIIB, this is the input resistance HIE, and this is the output admittance 1 over H naught. So this main portion, it remains the same, and with that we introduce any other element which is attached in the oscillator. So here we have a tank circuit that is constituting of capacitor and inductor. The any resistance of that inductance coil can be shown separately through this resistance, and the voltage, part of the output voltage which is fed back to the amplifier, it is through L1 inductance, and that is done with the help of mutual inductance. So the input current is IB, output current is IC. So that I think won't be a major problem for you to learn this circuit diagram. Now in mathematical analysis you can see that beta equal to 1, that is the main condition for oscillations for sustained oscillations. Now here voltage gain A of common emitter transistor amplifier, that we have also studied in our previous chapter of H parameters. So we use that formula directly. HFE, ZL, HIE, delta H, ZL, delta H is given like this. Now here you can see that ZL ZL is basically the total resistance of this LC circuit. Here you can see L and R, they are in series, and the combination of L and R, it is in parallel to with the capacitor. So the total resistance of the combination, it is equal to ZL. So Z1 is j omega L plus R, that is the reactance of inductance plus resistance. Then they are in parallel, so we can find ZL equal to this from equation 3. Also, beta, as I've said, feedback fraction. So beta is equal to feedback voltage over output voltage. So feedback voltage is that which is across the coil L1, and the total output voltage is across L. So this is simple formula for voltage across L1. It is j omega m into IL, that is reactance into current, and similarly total voltage will be total reactance plus current, R plus j omega L IL. So put all these values in equation 1, and we get this simple equation 5. All these things are solved, or these steps are solved in the book, so that won't be a, you can do that on your notebook. So now if we equate the real part, we get the frequency of the oscillator, that is given in equation 6, and if you equate the imaginary part, then we get the equation 7, that is the condition of sustained oscillation. So this is the value of mutual inductance which is required for sustained oscillations in case of tuned collector oscillator. So this was all about tuned collector oscillator. It's a very important question. As I said in the first slide, that there are total 5 number of oscillators. So today I have discussed with you in this video the first oscillator, that is tuned collector oscillator. So all the students, you must understand the whole concept of oscillator, and then try to write this article in your notebook, so that you can learn this for your examinations. So thanks for watching this video. Thanks a lot.